Okay, so the one thing I'd have you add to your notes, if you have these definitions down, is just put soluble ionic compounds under electrolyte. So you guys know what things are ionic, right? It'd be anything with a metal combined with a non-metal. NaCl is the one where we use consistently all the time. All right. Juniors, you've got testing that'll be coming up Monday and Tuesday, and we're going to get you an opportunity to look at some terms that might be on the NISA test, one form of or another. The Nebraska State Education Association will send out terms that would be helpful for you guys to know a little bit about before you take the NISA test. So I will plan, I'm going to try, I know I'll get you out the physical science terms that you can look at. And we're not going to really much study them in here because sophomores aren't taking it. I'll just give it for you for your benefit to look through. Okay? But, and then under non-electrolyte, you can put carbon-based compounds. And that's where we got sugar. Sugar is C12H22O11. Okay? Or glucose is C6H12O6. So it's anything pretty much. Now, if I say everything that's carbon-based, we're out of Kleenex. Ben, you want to go down in the office and get them? Thank you. Get 2 or 3 boxes. Non-electrolytes are carbon-based, okay? But if I would say everything that's carbon-based is a non-electrolyte, I'd be lying. So, majority of those, if you see it on a test and you see something with carbon in it, you pretty much count that it's going to be a non-electrolyte, okay? Now, in class, we did rates of dissolving. This dissolution means dissolving. We came up with 3 things we did to a solid to make it dissolve faster. What are the 3 things that you do to a solid to make it dissolve faster? Trevor? Heat up the solvent it's going in. That'd be 1. Jared?
Smash it.
Okay, smash it, meaning making it smaller size. And then what else?
Agitate it.
Agitate. Those are the 3 things. Now, this will be lengthy. So if you want to break it down into, put it in your own words, that's up to you. Okay? It's up to you. So if you put down the 3 factors would be, make sure the particle size is smaller. Okay, break it up before you dissolve it. 2, you would agitate it, stir it, or swirl it, or do something to cause the solvent to move around. And then 3, heat up the solvent. That would be fine. Okay, this goes in a little bit more detail than that. And so when you smash it up, you increase the surface area in contact. So you guys know if you spill something that's larger particles onto a table, you can pick them up pretty easy. So like larger crystals you can pick up. If you spill something that has really, really small crystals, like sugar or salt, it's granulated, it's pretty tough to pick up. Okay? Because it spreads out through the whole table surface area. Okay? So that would be an example when you want to increase the surface area. Now, sometimes in NISA tests, we'll talk about things that increase how quickly a reaction takes place. Some of these are the same scenario. So if we want a reaction to take place quicker, we'll want to increase the surface area. So we want to make particles smaller. When we make particles smaller, the reaction goes faster. Okay? If we have larger particles, they don't go as fast. So anytime we increase the surface area, well, what that does is mean you're breaking it down into smaller particles and exposing the greater number of those particles becoming contact. The more contact we have between particles and the solvent, the quicker the part breaks down. Okay? Agitation. It increases the rate of contact. You stir it up. I've got magnetic stirrers here. that sometimes I'm multitasking and have to do one thing, go to another to do a lap. And I'll just let it stir on its own until it's totally mixed up. So agitation will increase the rate of contact between the solute and solvent particles. And then the last one is the heating portion of it. And if we heat up the solvent, just like in a reaction, if we heat up, increase the temperature of a reaction, most times the reaction goes faster. So if you get, on an ESA test, you get a question that asks you, which of the following will cause a reaction to react faster? And if one of the choices would be make the particles smaller, that would be an example, yes. Or if it says heat up the reactants, then that would be a good choice. Okay? If it says cool down, that wouldn't be good. Okay? So if you cool down a liquid and try to dissolve a solid in it, or do a reaction when something's cooled down, the particles are moving slower, there are less collisions, and because of that, you have a slower rate of reaction. Okay? Okay, that's the last one. And then we'll give you notes on saturated, unsaturated, and supersaturated, and then do a couple demos with the two examples. Yesterday, first period, I couldn't get these to work. These are prime and ready to go. I've got my two solutions here that we can use and talk about, which would be good. You guys can see a visual example of what we're looking at. So there's different types of concentrated solutions, and we can label them three ways. We can say it's unsaturated, meaning it doesn't have much solute dissolved in it. It could hold more if you wanted to. If you wanted to mix more, you could. Most everything we come in contact with, solution-wise, are unsaturated. There's very few that are going to be saturated. Okay? Saturated means it can't hold anymore. Saturated, like knowledge-wise, sometimes you guys don't think you can hold any more knowledge. Okay? I can't hold anymore. It's too much. Okay? And then supersaturated is that for some reason you do something to the solution to allow it to hold more than it normally can hold. Okay? So those will be the three types that we'll look at. So don't write this stuff down. This is beyond what you guys, I'm going to ask you to know.
Wait, so what is like when someone gets like a saturated fat or whatever?
Well, that saturated fat is one where you don't have very many in the chain. You guys, there's a chain of carbons, and in that chain, if you have some double bonds, it takes away hydrogens on the outside. So what happens if you have what's called a saturated fat, means you've got lots of hydrogens surrounding the molecule. If you have an unsaturated fat, what happens is you've got multiple bonds that occur between carbons, and you have less hydrogens that will surround the molecule. That's the only thing that's different. Saturated, lots of H's will surround it, and then unsaturated would be where you don't have as many hydrogens around.
What's like, is there like, what's the health benefits or whatever?
You know what? I'm not the guy to ask on that, because I don't care. I probably should, but if it tastes good and you don't overindulge in certain foods, I think I'll be fine. And that moderate exercise I got to work on. Exercising every once in a while, especially as you get older, metabolism kind of goes down.
You just come up to the wrestling deck with this.
What's that?
You just come up to the
No,
wrestling
I'd last about 30 seconds, and I'd be. I've done that before and tried to do it, and I was done for the rest of the practice. I was like, no. Well, I'd have to do that if I would be able to. I'd have to be able to do that to last. Okay, so you have three saturated levels, they're really easy to understand. It's either they can hold more unsaturated, they're holding maximum amounts, or for some reason they're holding more than they really should hold. So how do you get something to where it can hold more than it really can hold under normal conditions? Well, what you have to do is you have to manipulate it to where it is saturated and then lower the temperature so that it becomes supersaturated. And I got a couple examples up here of how we've done that. Okay. So let's take a look at a page in your book that you're turned to. It's 410. Now, tell me some things about this table that if you had some questions to ask that are asked about this table that would be important for you to know, like on a test, if there's a multiple choice test. And, what are some things that you see that will help you answer questions on this table? Throw out some things that you see.
Temperatures in Celsius.
Okay, so the temperatures, multiple temperatures, right? Do you guys see any trends? Remember we talked about trends, and on ACT tests, a lot of times questions are based upon trends. So, do you guys see any trends happening with the temperature and then the numbers that are listed out there?
Higher temperature, more solubility.
Okay? So, most of them, as you go across, they tend to get more and more you can dissolve, right? And the bottom two are gases. Everything else are solids. Now, there is exceptions to that, but most of them you can dissolve more as the temperature goes up. Okay? What is solubility? What do those numbers represent? What are the units for solubility? What do they tell you?
Grams.
Okay. Grams of solute. Just that?
Per 100 grams of
So, they stipulate two things you got to know for solubility. Grams of solute in a certain amount of solvent. And how much are they talking about? 100 grams. Okay. Now, are these max numbers? These values that are in 100 grams of water, are these maximum amounts you can put in 100 grams of water?
Yes.
Yes. So if they're maximum amounts, what are they? What category would they be? These three.
Saturated.
Saturated. They're maximum amounts at those temperatures. Okay? So basically they've done this by experimentation. That's the only way they've done it. They say, okay, we're going to take this solid and we're going to dissolve it. We're going to measure how much can dissolve at 20, 40, 60, 80. So they've measured all those values out. Okay, because there's not a constant rise sometimes. Sometimes there's a constant rise, but there's going to be a maximum point where you can't dissolve anymore. Turn over to page 414. Some of these have pretty constant slopes, don't they? When you look at them, pretty consistent. But some of them aren't. Some of them kind of curve. Some of them get to the point where they get a little steeper. Or you can use this in which to analyze the data too. And these are solubilities as well. So if we look back at that initial table on 410, go back and forth for a particular substance that's listed on both pages, they would be the same. They would intersect at 20, 40, 60, 80, the same on the graph. So, do you think the graph is more helpful, or do you think the table is more helpful? And why? Why would the graph be more helpful?
Because you can see the trends.
You can see the trends, maybe easier, possibly. What else?
You can pinpoint it by doing crosshairs and certain
Right.
points.
And that's called interpolate. When we do it on the lab quest, it's interpolate, or take a look at the solubility and then cross-reference it to the temperature and vice versa. On the table, could we do a temperature of 30 degrees?
No.
No. On the graph, can we do 30 degrees?
Yeah.
Okay, and it'd be more of an estimate too. I have a hard time reading this graph, and I don't like the way they laid it out because they've got white lines as their lines.
Yeah, I didn't see it.
There's white lines there. I don't know why they didn't do grayish lines so you could tell where they intersect. My eyes aren't very good anyway, and so that doesn't help.
I didn't even notice that by mine.
Yep, gotta look close. Okay. So, yes, Adam.
Wouldn't you be able to, like, to get like a temperature of 30, wouldn't you be able to just take the center?
You could take the average, you could have halfway point, if you know it's a slope. Because if you look on that other page, they're not all going to be perfect slope. So that's assuming that the change in the solubility to the temperature is a direct relationship. Then you could, sure, you could estimate what it would be. Probably be pretty close. Okay, so looking at the table, I want you to look at A, and I want you to determine if it's saturated, supersaturated, or unsaturated. Guys, don't visit and talk. This is something that will help you on your worksheet, so I don't have to answer those questions a second time. You can get it now. Okay? Don't put that up for now. Look on page 410.
Got it.
Yeah, just put it up behind you there on the table. So is that saturated, unsaturated, or supersaturated?
Saturated.
Okay, so this matched up with on the table at 60 degrees, right? So if the number 287 matches up with the number on the table per 100 grams of water, that's a really easy question to answer. That's saturated. Okay? See? So page 410, we find Ki at 20. Saturated, unsaturated, or supersaturated?
Unsaturated.
Okay, what's the saturation level for this one?
144.
144. So this one says the table at 20 degrees Celsius, 144. So how many more grams can it hold? 4 more grams. Then it becomes saturated. If this said 150, then it would be super saturated. Okay?
What's the IN stand for?
IN. In. Means it's placed into 100 grams of water. Okay? So this would be unsaturated. And the last one. 100 or 1.25 grams of lithium carbonate at 20 degrees Celsius.
Unsaturated.
Is that unsaturated as well? What can it hold? 1.33. Okay, so unsaturated as well. Questions. So pretty easy questions to answer. Anybody with not any knowledge, could they answer this question? They have to know a little bit about saturated, unsaturated, supersaturated. But they could answer this question. So, like on an ACT test, they might say, all right, this is a saturated solution, can't hold any more. This is unsaturated. And they might ask you questions like that. All right? Here might be a tougher question that you'd be asked on an ACT test. So now, they have 100 grams of KCl and 250 grams of water. So no longer do we have our 100 grams of water as our constant. And it says, okay, is this one saturated, unsaturated, supersaturated? What do you have to do to this to determine if it's one of those three?
Take times 2.5.
What's that?
Take times 2.5.
Take what times
The
2.5?
temperature, or the amount at.
Okay, you could do that way. I'm going to do a little different. Okay, you could definitely do that way. What he's saying is he knows that this is 250, it's 2.5 times the amount of water. So he's saying in the book, it's per 100. So I can take that number times 2.5 and compare it to the 100 grams. Okay? What I would rather do is I would like to go the other way. And I'd like to say 100 grams over 250 is like how many grams to 100? So instead of Timesing it by 2.5, I'm going to do what?
Five.
Divide basically by 2.5. Okay? So somebody do that. Tell me what your answer is in grams. So somebody go ahead. You would cross multiply. So it'd be, what, 10,000 divided by 250? So how many grams is that going to be? 40?
I think
Yeah, it's 40.
40 grams of KCl. What is it on the chart?
40.1.
So I would pretty much say, with significant digits, if we rounded, it would be saturated, wouldn't you say?
Yeah.
Okay? So that would be saturated. It's the same. Okay, do the next one on your own. 38 grams. I got to tell you what the stuff is, though, because otherwise it doesn't make any sense.
38 grams.
Okay? You can make up your own stuff here. Let me see which one I picked here real quick. We're going to say it's Ki. So go ahead and do that one real quick. Do it the same way. So we have 38 grams of Ki and 25 grams of water. We want to know if that solution is it saturated, unsaturated, supersaturated. So you would say 38 grams over 25. That equals X over 100.
Whoa.
Okay? X over 100.
How'd you get the 25 again?
It's right here. 25
25
grams of water.
I know it. Okay. Said I know it.
So what would that be? What would your answer be?
152.
152? So is that saturated, supersaturated, or unsaturated?
Unsaturated.
What can it hold? 160?
162.
Okay, 162. So this would be unsaturated. Okay, questions?